So this is the last lesson in chapter 11. We're going to go over surface area and volumes of spheres. So everything that's on the screen is in the notes that I gave you. Everything. The only thing that's not is this slide, and you guys care so much about this slide. It tells you what you're going to learn. You're going to learn how to find the surface area and how to find the volume. If you are doing this from home, you can turn in your student journal to page 351, but otherwise you guys have the notes in front of you. All right, so we're going to talk about the lingo of a sphere. You have blanks on your notes. We're on this side. A sphere is the set of all points in space equidistant from a given point. That given point is called the center. And that's mind-blowing. The center is in the middle, in the center of the sphere. So it's inside. You can still have a radius of a sphere. It is a segment from the center. No. It is a segment from the center to a point on the sphere. A chord, just like a chord of a circle. A chord of a sphere is a segment whose endpoints are on the sphere. And of course there's a diameter. It's a chord that contains the center. So boom, boom, boom. Those are all words you've always used before, except for now they deal with a sphere, a three-dimensional circle. What relationship does the radius have with the diameter? It's half. As with circles, the terms radius and diameter also represent distances, and the diameter is double or twice the radius. The radius is half the diameter. Okay, so that still applies here. Okay, there's fascinating information. You got a circle. When you connect a plane with a circle or intersect a plane with a circle, it creates hemispheres. You guys have heard of the word hemisphere, have you not? Southern hemisphere. No, not atmosphere. Hemisphere. Hemisphere. And it comes from this. Okay, because when you have a map, you have to cut the world in two, yada yada. Your first formula, surface area. You can look at Davion's. Surface area, you see that formula right in the middle of the page? You'll want to write that one down. Surface area equals 4 pi r squared. 4 pi r squared. This is the second last formula you're going to learn in chapter 11. Guess where it comes from? Let's see. Surface area is the outer of an object, correct?
Yes.
So, where does pi r squared come from?
Circle.
What about it? What about it?
The radius, diameter.
Pi r squared is what? It's a particular formula. It's the area of a circle. Y'all, my goodness. So if you laid out like a baseball.
What?
Y'all ever seen the stitching laid out like this?
Yeah.
Okay. Well, whenever you take any circle whatsoever, it creates 4 circles. And they overlap. So that's where the 4 comes from. There are 4 areas of the circle. So 4 times pi r squared. So that's where the formula comes from. So let's do some problems together using our formula. Surface area equals 4 pi r squared. Oh dear.
Because we're in math, Vicky.
Okay. 4, we're going to plug in our radius. 4 pi, what is the radius of our circle? 8 squared. Type it in your calculator, write both answers. You get 256 pi, which is equivalent to
84.25.
Yep, inches. It is area, so inches what?
Squared.
Squared. Both answers are circled. Questions on the first problem?
Do we need both answers?
Especially whenever you're doing your homework, I would put both answers, because sometimes the key, because I literally just take the key from the book and put it on the screen.
Do we pass up our homework?
I took your homework from you. Yes, we did. Not right now. Never in the middle of a lesson. fine. Surface area equals 4 pi r squared. But what did they give me in letter B?
Area.
They gave you the circumference.
Circumference. Circumference is the distance all the way around the circle.
So C equals pi r squared.
Nope, that's the area formula. No, wait.
Pi B.
Well,
That's pause. You guys are just yelling out things. You're not actually letting me speak. There is a circumference formula, but it has radius in it. Pi times d, that's wonderful, but that doesn't tell me anything about the radius. Thank you. 2 pi r.
that's a thing still?
Yeah, it's always going to be a thing. So you can do one of two things. You can use that lovely brain between your ears. It was 2 pi times the radius, and they got 12 pi. What did they multiply by 2 pi to get 12 pi? 6. So the radius is 6. Here's the other option. You know the circumference is 12 pi, so guess what you can do with that? You can plug it in. And then you would solve for the radius. You would divide by 2 pi, and you would still get 6. Same thing. But either way, our radius is 6. From here, we just plug it in. So 4 pi times 6 squared. We get 144 pi.
452.39.
And we are in feet squared.
How many points off is it if you forget the measurement?
It's only a little bit. Questions on the first two problems? Are we all good? How we found the radius?
Yes.
If Ben's good, then we're all good. Oops, sorry, you were still writing that. It's okay, you got it. All right, this is the last one we're going to do regarding surface area. It says find the diameter of a sphere. So what did it give you?
The surface area.
The surface area. We know surface area equals 4 pi r squared. Does that help you find the diameter as it is?
Yes.
Well, it helps you find the radius. After that, what relationship does the radius have with the diameter? It's half the diameter, so we can double it to find the diameter. So what we can do, let's find the radius first so that we can find the diameter second. So what can we plug into this formula? The surface area. Yep. 20.25 pi, don't forget the pi, is our surface area. How do we solve for r?
Square.
Nope.
Oh, wait.
Divide by 4 pi. Oop, that's not a 4. You get 5.
0.0625.
I didn't get 5.
Then you got it wrong.
Did you put pi in the top and the bottom?
Oh, not at the top and bottom.
Yeah.
I didn't see that.
Yep. The opposite of squaring, we're going to take the square root.
25.6.
What? 2.25.
What?
What are you doing?
doing? Oh, we gotta take the.
So you smoking?
Shoot. We gotta take the square root of it?
Yeah.
What the heck?
Listen. Once we find the radius, what do we do to find the diameter? Yeah, you were tempted to circle that, weren't you? Times 2, it's 4.5 centimeters. Why isn't it squared?
Because it's diameter.
It's the diameter.
The diameter.
Questions about this problem? Okay. So just a reminder, be sure to multiply the value of r by 2 to find that diameter. Then we have volume. Your new formula, you have a blank. 4/3 pi r cubed. Most common mistake, students don't write cubed.
I just put square.
Yeah.
Everything cubed or just
Like I've been teaching it for a while.
R cubed, buddy.
4/3 pi r cubed. So we're going to do a problem. We're going to start small, work our way up. We got a soccer ball. It tells me 4.5. What is labeled 4.5?
The radius.
The radius. So we know volume is 4/3 pi r cubed. A way that I remember to make sure I write down my formula correct. Both of these are 3's.
Oh.
Yep. It's fascinating. 4/3 pi times 4.5 cubed. You're going to get a larger answer. Here's why. 4/3 is greater than 1. Pi is 3.14. And then 4.5 cubed. It's going to be big. Yep.
Good night.
How? It's 243/2. I'm going to come over there. Don't. Well, type it back in. Which is 381.7 inches cubed.
Which is far from that.
It's okay.
I did that first, and then I did which.
And then, where's the pi? So times pi.
I just forgot.
Ooh, okay. Okay, questions about this problem? You do not have to turn around and talk to the person next to you because I'm talking to someone else.
Sorry.
If you're sorry, you'd stop doing it. This is our last problem. Oh, actually, we have one more. Surface area. The surface area of a sphere is 324 pi square centimeters. Find the volume of the sphere. So let's think about this. What is the surface area formula?
4/3 times pi
Nope.
r cubed.
You're wrong. That's the volume formula.
4 pi r squared.
I already got it up here, guys. So look, listen. Besides pi, what do they have in common? R. What does R stand for? Radius. So think about this. They give you the surface area. The surface area is 324 pi. So let's plug that in just to get your mind thinking. 304 pi. So what could we solve for in this problem that might help us? The radius. If we solve for the radius, we can plug it into the volume formula. Okay? How do I solve for the radius here? What's next? Divide by 4 pi. 81. Take the square root. What does R equal? Do not circle that answer. That's not the answer that we're looking for. We are going to use it. We know that volume is 4/3 pi r cubed, so plug it in. It is going to be. It's like 700. No, 900.
It's 972 pi.
Yeah, I'm getting there. Which is equivalent to
3,533.63.
That's so wrong.
I
I said 3,530.
It's a good thing I was reading it. Kaboom.
Of course, I've got 7
Do we have any questions on this problem? Why we plugged in the surface area? Why we solved for R? Yes, dear.
Why is there a 4/3 in the front of it?
Because this is the volume formula?
Yeah.
You're asking why it's 4/3?
Because
Galileo thought it should
be there.
I'm sure there's a derivative on the line somewhere. Go ahead on your own time. Look up why it's 4/3 pi r cubed. But personally, 23 out of 24 of you don't really care. Maybe 22 of you.
Hey, Miss Marshall, can you give me that paper that you were giving me before about derivatives? See if I can do it.
Not right now.
I mean, like later.
Sure. Okay. Find the volume of the composite solid. This is our last one we're doing together. So I see that there are two objects Are they adding to each other or taking away from each other? They're taking away from each other. It's not like, listen please, it's not like there's a cone up here that would be adding. There's not. So we have an outer object and an inner object. You have done this before. You insist that you have not, but you have. Where you have like a box, and part of the box is shaded and part of it is not. Promise you, in your however many years of education, you have done this before. So what would we normally do if we wanted to find the area of the non-shaded?
You find the area of the whole thing and then the inside circle, or the inside rectangle, and then subtract it.
Perfect. That's what we're going to do here. Find, except for instead of area, we're finding the volume. Find the volume of the outer object. What is the shape of the outer object? It's a cylinder. Does a cylinder, I told you that all volume, except for the sphere, it falls under the category of a prism or a pyramid. Which one does this most look like? Prism. It is a cylinder. So you're going to use the formula. What is the formula for a prism?
Area of base times height.
Praise the Lord. Area of the base times the height. All right, so what shape is the base of a cylinder?
Circle.
Circle. So the area formula of a circle is?
4 pi.
I'm getting there. So what is our radius?
2.
2. 2 is right here. And then what's the height? 2. 2 is right here. So 2 squared is 4 times 2 is 8. So 8 pi. That is the entire cylinder. Okay, but not all of the cylinder is filled out. Part of it is cut out. What shape does the top most look like? Half a, but three-dimensional. Half a sphere. Because the other part's not there. So here's what you're going to do. You're going to find the volume of the entire sphere. Then how do you find half of that? Cut it in half. So we're going to find the volume of our sphere. So 4/3 pi r cubed. What is my radius? 2. 2 cubed is 8. 8 times 4 is 32 over 3 pi. I'm getting there. But that is the entire sphere. If you were to try to subtract 32 over 3 pi from 8 pi, you would get a negative number. Can you have negative volume?
No.
You cannot. So, you haven't finished. You divide it by 2. Why do you divide by 2? Because this is the whole sphere, but there's not a sphere. Like the sphere appears invisible. It's not there. That makes sense. So only the half, bottom half, is what's inside of our cylinder. All right, so we're going to take 8 pi right here, subtract our 16 over 3 pi because it's cut out, and we get 8/3 pi as the answer.
Oh, it's over 3. It's over 3. I did it
Yeah.
over 2.
Questions, comments, concerns? Okay, take out one sheet of paper. One sheet. Again. So I want you to do 3 different columns: area, volume, and surface area. It's here for your notes. So. Area formulas. I'm going to go down the row and write them so you can just keep up. What is the area formula for a circle?
Pi r squared.
Pi r squared. For a square. S squared, yep. I'm getting there.
Come on, Davion. So, slow down.
Rectangle is length times width. Triangle is 1/2 base times height. Keep in mind the hypotenuse is never the base or the height. Sorry, that H doesn't look like an H.
Is it ever used?
No. I mean, if you to find the other side in the right triangle. That's pretty much it. And then a trapezoid.
1/2 B1 plus B2 times
Yep. And B1 and B2 are very special because
Parallel?
parallel
Would you have a triangle with hypotenuse
is never the base or the height. So let me just explain something to you. These are not new area formulas. They're formulas that you have used since you were wee little. So whenever I went into volume with you guys, these were an expectation that you already knew them. So whenever you say that there are a lot of formulas, in my mind, these should already be in your long-term memory. You guys know the difference, obviously, between long-term and short-term. Short-term is you cramming something before a test about the Mongolian Huns or whatever, right? That's short-term. How do I know that? Because I've seen Mulan. Okay. Long-term is something that you can recall later on in life, like the Declaration of Independence date, things like that. These should be stored. These should be stored in your long-term memory because they're never going to change. And it's going to be assumed when you get in higher maths that you know area formulas. Okay? Prism. Volume formula, second column.
Area base times height.
Yep. You never write area of the base. I need you to write it this one time in your entire life. Because you guys consistently write B for base, and that's not what it is. He at least wrote area of the base. Alright, pyramid.
1/3.
1/3 area of the base times the height. Sphere, last one. This is the only one that is completely new to you today. R cubed. And then our last, surface area of a cone. I always write SA.
Plus pi r times h.
Close.
No?
Pi r squared, you're super close.
Whoa.
But it's pi r L, not H. I don't know where H comes. H is not, you want to make sure it's not the height, it's always the slant height. So if you want to write that, this always has the slant height. Whereas the volume of a cone has the real height.
How can we even put volume on?
Because a cone fits under a pyramid. Because a cone is 1/3 pi r squared. Where does pi r squared come from? It's the area of the base. What shape base does a cone have? Circle, which would be pi r squared. And then times h. So that's why I didn't put it up here, because a cone qualifies to be a pyramid.
I can watch the video you're about to upload.
You what?
She can watch the video you're about to upload.
Yes, you can. A sphere, the surface area for a sphere, this is the last one. Surface area is 4 pi r squared. So these are all of the formulas. I'm telling you to help your mind. These 3 volume formulas, know them. Don't know the individual cone and cylinder. A cylinder, does it look more like a prism or a pyramid? Pyramid. So, a cylinder? Prism. Cylinder. Cylinder looks like a green bean can. Looks like a prism. So it falls under the prism category.